Then come grab a book, you definitely may. If you want to get on your phone for a Google Classroom assignment, maybe you're getting into section 5, etc., you may just get that phone gone as soon as you've written it down, unless you have Calc Chat open or something. But once again, if it's being used as a resource, it should kind of be over here on your desk and not necessarily something that you're like posing or let's not do that. Okay? Let's not have it be a distraction. So a couple examples, maybe you want to be paying attention, maybe you just want to be listening because you got stuck somewhere in homework. I do have, oh, I'm sorry. No, I do. I have the book open off to the side, so before I transition to section 5.5, I will ask if there's someplace someone is currently stuck in homework that might help the rest of you guys. And if you have not done the problem that they are on, you can always flip to your workspace and write down what I talk about, the hints I give, etc., to be ready for tonight. All right, guys. The one big one, and to be honest, it's one of the biggest reasons that I'm basically taking a little more time and extended your deadline, is that we didn't get to do one of these triangle problems, and to be honest, they really show up, they show up pretty frequently in 5.4 and 5.5. And they're so basic, and yet they can be so confusing if you don't know how to do them. So I figured instead of kind of breezing over it and rushing you guys to have the homework totally done for today, I'm going to slow down just a second to do one of the triangle problems. And then I think I have like a proof or something that I can show you too, that whole plugging into the unit circle. I think both of those, this page and the next, are super helpful for not just finishing 5.4, but being able to do the same skills in 5.5 with new formulas. So that's my goal, that's my objective. And to be honest, they don't say anything about a triangle. There is nothing in this problem that says use a triangle. However, the only possible way forward is making triangles. So, something important for you guys to recognize. Whenever you see a sine, a cosine, a tangent, a trig equal to a fraction, there's an understood make a triangle. Okay? So, in this one, usually they tell you a quadrant to go ahead and put these in. Sadly, in this one, it didn't say specifically, but I think some of you might get confused on that in homework when that comes about. These triangle problems in homework should appear, well, actually it's pretty easy, whenever you start seeing fractions. And so you start seeing fractions right about, here we go, the 40s and the 50s. Or at least the 40s and almost the 50s, or the beginning of 50s. Because they start giving you different fractions, but if you guys notice, they also say, hey, they're in this quadrant, or hey, they're in this quadrant. I'm going to assume that I was doing 42-ish. Can we check the notes real fast? Yeah. Am I doing 42-ish? Okay, cool. So in that one, we're supposed to be in quadrant 2, so let me model that also, because maybe just a couple of you were like, what? Quadrant 2? Okay. Quadrant 2. Got it. To make my triangles, I have you. Now, you probably wouldn't think by drawing this first. I'm just kind of thinking ahead. But hopefully you would realize quadrant 2, or at least now you can realize, I need to make a triangle in quadrant 2, or with an angle that lands in quadrant 2, with an opposite of 5, a hypotenuse of 13. I'm trying to make it kind of true to the fractions, like he's half-ish, a little bit less. However, you guys realize from these two numbers I'm missing something. But do you realize why I made 5 opposite and why I made 13 hypotenuse specifically? Sine is opposite over hypotenuse, right? So what am I going to be assigning these two to if it's cosine of an angle instead? Adjacent over hypotenuse. So I have to think about the trig. The trig points me to part of SOHCAHTOA, and that part of SOHCAHTOA tells me, oh, one side is this, the other side is that. Cool. However, a triangle has 3 sides. I only have 2. How can I always solve for the third? So you could do something like 13 squared is equal to 5 squared plus my unknown squared. But long story short, if you guys have been around Pythagorean triples, oh dear. And if you remember, there is something called a 5, 12, 13 triangle, like a 3, 4, 5. But the problem is plus or minus. Why am I putting a negative 12? Yeah, you could say it's going to the left. You could say it's in the second quadrant, so adjacent or cosine is negative. Different ways of thinking about it. But it being in the second quadrant dictates I have to put the negative there. Now, that's triangle U, but there's also a triangle V, right? I'm going to make this blue just so that we can color code it a little bit. 5 is my hypotenuse now, and 3 is my adjacent. It's going to kind of make it more like this-ish. I don't know exactly what the angle is. Now, some of you might be thinking, sine inverse, cosine inverse. I'm going to find the angle, and then I'm going to plug in the angle, then I'm going to subtract, and then I'm going to do cosine. And all of it's going to happen in my calculator. In some ways, it'd be good, but in some ways, you'd be dealing with some nasty decimals. And every time you have a decimal, you round, and every time you round, you compound error, and every time you go like less than, every time you kind of fudge here, it's going to end up fudging there, and here, and there, and then it's going to end much differently than ideal or than you would wish. But coming back, we don't want to have all of that rounding, number one. And number two, anytime the directions say find the exact, that means you're not allowed to go to a calculator. That means we're looking for a precise answer, which means with a pi or with a square root or with, what else is awkward? An awkward fraction. No decimals, no rounding. It's able to be geometrically done. Trigonometrically, geometrically done. Now this one, we're able to label our -3. There's a quick reminder that we're supposed to have an opposite. Well, we need to think about the opposite right now. An adjacent that needs to be negative. We need to actually fill in the opposite for this one. We don't have it because it's cosine. But this one's a lot easier for most of us. It's just going to be a 3 what? 5 triangle. Got it. Why are we doing this? Because the only way to solve exactly, geometrically, trigonometrically, cosine of u minus v, when I cannot know u from the unit circle, I cannot know v from the unit circle, that's not my 1, 2, 3, or 3, 2, 1. It's by using my formula that says, okay, hold on, geometrically I can look at each of these triangles separately and I can use the clues when dealing with my difference formula for cosine. Now, you guys don't have to have these memorized anytime you're doing problems. I'm reminding you. Make a formula sheet. Be using the formula sheet in class, in homework, preparing for the test where I make you the formula sheet. And you can use those formulas anytime you're doing a problem. But in studying for the formulas, do you guys remember how this formula goes?
Cosine of u times cosine of v minus sine of u times sine of v.
I love it, except for the minus. Why is it a plus? Does anyone remember my way of remembering it? Yeah, cosine, the signs change. Sine, cosine, change. And, if it helps, co means with or together, so it's cosine, sine. Co is with co, and sine is with sine. But anyway, now that we have the right formula, who is cosine of u times who is cosine of v plus who is sine of u times who is sine of v. That's exactly what the formula says, but would you know to go look at the triangles and take that information properly? Cosine of u, adjacent over hypotenuse. If you have the triangles, it's easy. Cosine of v, go to the other guy, adjacent over hypotenuse. Remember, they're two different angles with two different triangles. Sine of u, opposite over hypotenuse of the u. Sine of v, the opposite over the hypotenuse of the v. Oh dear. If you guys want to write a note to yourselves, it's really easy for people to make a mistake and not get rid of the sines and cosines. Hello? Yes. To the main office? Okay, thank you. Vanessa, main office, kiddo. I think you're going to the coaching or something. So then coming down here, who is cosine of u? A strict substitution. Cosine of u gone, his fraction is in. Cosine of v gone, his fraction is adjacent over hypotenuse in. The most common thing that kids do on quizzes and tests and these problems is to keep writing the cosine, cosine, sine, sine, and it messes them horribly up. This is cosine, this is cosine, this is sine. Now, you only have to simplify the numbers. Although just a few of you I'm worried. Emma.
Can I reserve my chocolate?
Yeah. Or I have one on my podium if you want. But either way. Fractions. PEMDAS. Multiply, multiply, then add. So multiply. 36. What do we got? 66? You guys agree? Plus 20 66. Ends up being 56. It's exact, it's precise, it's a fraction that is the perfect quantity of cosine. whenever you see SOHCAHTOA, sine, cosine, tangent, equal to a fraction, and I'm just showing you in homework one more time, whenever they give you clues, it always means draw triangles for each individual angle with the appropriate sides, opposites, adjacents, hypotenuses, and the appropriate signs, SIG and S, positive, negatives, in the right quadrant. Okay? Then use the correct formula to plug in. I don't think I gave you any crazy ones, but there are some crazy ones in the section. Can you guys look 41 to 52? Are there any of these that don't exactly seem straightforward? If you fully understand what we just did. And you're like, okay, I think maybe I can apply that to a sine or a tangent. But does anything look weird, 41 to 52? Yeah, secant. And it's v minus u? It's backwards. Hold on, who is secant? Secant of anything is 1 over cosine of the same anything. So just for cotangent or cosecant or secant, you don't have formulas for those, but it's no big deal because you can just make it 1 over cosine of v minus u, which would be, in context of the formula, 1 over co, but it'd be co v minus co u. And then cosine of sines change. Sine v, sine u, which ironically doesn't actually change anything. Because if it was u minus v, it would actually be the exact same thing for cosine versus v minus u has to do with the even and odd even property of cosine. But you guys don't need to stress about that. Anyway, if I was to give you a nasty, tricky one, there's totally a way of doing it. You just have to use what you know of secant and then apply the cosine formula properly. Triangles, triangle type problems, them giving you information of triangles is one thing you'll see in 5.4 and 5.5, both with these formulas and the other ones to come. But you might also see T-proofs or equations where part of it you don't know, but part of it you do. And if you don't use the unit circle, you're going to totally get stuck and there'll be no way forward. You'll be totally stuck, unable to move forward. Sometimes the way forward is to look back. Anyway, we know in T-proofs. Why am I even doing a T-proof? Why did I even draw a T? Well, the equal sign, couldn't that be section 5.3 where x equals like pi over 6 and 11 pi over 6? How did I know, even though there was an equal, that could be 5.2 or 5.3? But technically, what was the word that they use more often than proof? Verify. So if you see that, you just have to know, oh, it's always true, and I have to show it's always true, as opposed to conditionally true. Which would be solve. Evaluate, solve. Usually solve. I'm going to definitely choose the left side, yeah? Anybody want to choose that one? Have fun. 0 comes from infinitely many different places. Okay. I'm choosing the left side. Is anybody's brain thinking of, hey, distribute cos and distribute sin? No. I think a couple of you maybe, yes. But those of you that said no, good, because that's horribly illegal. We have to use our sum and difference formulas. But some of you were like, oh, no. Aren't those sum and difference formulas a bit long? I'm going to draw my T a little lopsided and pretend that that was really down there. Because what do I need to do next? If I cannot distribute, there's nothing else I can do unless I go to my cosine u minus v and sine of u plus v formulas. Right? Nathan?
The co-function.
Just if you want to see what Nathan's looking at, because you guys are going to have all the formulas on a page on your test, and some of you would make the same mistake. If you look in section 5.1, go back to section 5.1 real fast. It was the big old massive basic table, or basic identities section. The first place, we covered all sorts of trig formulas. For the second time this year, actually. Look at the co-function properties. Could or can I use one of the co-function properties? Yes.
close.
Yes, you would think yes, but the answer is no. Why? What's the difference? It's so close. Oh, it's plus and not minus. But pause. If it was a minus, should we use the cofunction property? Yeah, it'll save time. So you're allowed to use properties from all over the place. And on the test, maybe in a T-proof, you'll be using properties from all over. And Nathan, honors was totally like, let's do it. And we started, and I was like, wait, it's a plus, guys. We had to slow down. So good idea, and if it was possible, would have totally done it. But since it's a plus, not a minus, sadly, no. And it has to do with the complementary angles. Sorry, you guys, there you go. Complementary angles in the first quadrant. Pi over 2 minus is complementary, so hence cofunction, but pi over 2 plus, the whole property breaks down. Okay, so you're not supposed to have these memorized, at least not for a problem. You don't have to. So I'm just going to go ahead and say, Coco, bring my memorization to the forefront. Plus, good, because cosine and sines change. Sine. I'll let some of you practice. Does anybody know the other one? Good, not with or together, right? So sine of first, cosine second, plus because sine stays the same. Yeah, it has to be the other way. But technically, multiplication is commutative, so I guess if you memorize it differently, it's okay, as long as you're really careful. Because if it's like the minus one and you have these switched, it's not going to be the same. Couldn't have used the unit circle here. Why all of a sudden can we start using the unit circle now? Oh yeah! You guys just take a sec and look at pieces that are in here. Cosine of pi is totally unit circle. Sine of pi, totally unit circle. Sine of pi over 2, Cosine of pi over 2, Now, if you're one of those actual, like, good old-fashioned Mr. Che unit circle people, you'll remember your coordinates on the axes, and that might help as far as 1, 0, 0, 1, negative 1, 0, 0, negative 1. Probably the easiest way to think about these. And if you remember that cosine is x for all of these, well, pi, well, that's easy, that's negative 1. Sine of pi, well, that's easy, that's 0. We'll fill in the rest in a second. Sine of pi over 2, that's 1. Cosine of pi over 2, that's 0. If you are a sine and cosine graph kind of person, maybe you could remember that sine. Sine at pi over 2 is up, so he's 1. Sine at pi is in the middle, which means 0. Cosine at pi is negative 1. And cosine of pi over 2 is in the middle, which is 0. There are different ways of thinking about it. Cheater chart people. Pi measures up with 0. And so you get your 1 and your 0. Yeah, your 1 and your 0. From that, you just have to make them a negative. Anyway, unit circle stuff. So not today's lesson, but it is being used. Just quick reminders. Filling in. Seems annoying until you start realizing anything times 0 is gone, right? So all I have left is negative cosine plus cosine. Oh, what's negative cosine plus cosine? They cancel each other out. Which will always occur regardless of whatever is in the theta position. That's why it's an identity. Dun, 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 dun. So, remember, your brain's going to try to maybe do some math stuff that's illegal if you're not paying attention to the formulas. You might try to do some crazy, not times. So you need to have those formulas in front of you. You don't have to have them memorized to recognize, oh, there's a way of doing that. There's a legal way of doing that. But then remember, some of these, you might just bring in the unit circle at some point and make, it could make the expression a lot simpler. Guys, technically, I mean, there are some other ones that we could do. This would be solving inside like an interval 0 to 2 pi. I would use the exact same strategy to simplify this guy with a sine, cosine, cosine, sine. Use my unit circle for those pieces with pi's and then combine and solve. That's section 5.3. But long story short, I'm pretty sure someone out there would at least like me to go over some sort of question in homework. So is there a place anyone's gotten stuck in 5-4 that you want me to help? Nikki? 27. Emma? 14. Kimian? 14. And 27? 36. Oh, so excited. Don't get lost. Okay, let's start with 14. Let's go to 27. And if we have time, Matthew will go to 36. Okay, 14. Ooh. Emma, is this one of these? Do everybody? Oh.
I'm just confused on how to start it.
Okay. So, if you look at negative pi over 12 as is, it's totally not unit circle, right? So if I wanted to do, give me a sec and let me make it all better. Edit, copy. Let's do this. Okay. What it ultimately wants you to do is answer the question, what is sine of this? What is cosine of this? And what is tangent of this? But the struggle is it uses the word exact, which means it's geometrically, trigonometrically possible without using like your calculator approximation. All the programming is approximation techniques. But you're like, it's not unit circle, so what can I do? They've given you the input of what you need to consider. Technically, if you were to get common denominators, pi over 6 minus pi over 4 is pi over 12, which means I can rewrite this.
Oh, okay.
Got it? Mm-hmm. We need to do it for all 4. Kimian, pause though, is that enough?
Yeah.
Okay. For the rest of you guys, I'm not going to finish. But just in case that's not enough, I'll just do one more step. And I'm going to do one more step with tangent, just because I don't think we've done any tangent examples of sum and difference, so why not? Tangent is, okay, this is just how I remember it. Sine over cosine, which means same over change for the signs. Co is with or together, which means the tangents are together. And yes, I kind of have to have memorized that it's 1 with a sine and then the 2 tans. Sine, they're not, so I split them up. But once again, you would just steal this from a formula page. Sine and cosine, very similar. You'd have to use the sum and difference formulas for those. But then as soon as you plug it in, now, some of you might have seen in homework, there were times you could go from this and be like, forget all that work. I'll do this instead. This one won't work because we can't get to the final answer by simplifying down because we don't know that guy. But we can get to the final answer by using the unit circle piece by piece. You're not going to like it because there's a complex fraction. Oh, how many things in Precalc do you not like that are technical of your math classes? If only you'd gotten them solid back then. The struggle of the entire math department at every school ever. Pi over 6. Square root of 3 over 3. 1 square root of 3. Got that guy. Pi over 4. 1. 1 plus. Oh, we already found these dudes. Actually, this guy isn't too bad because that's just a 1. We end up with. You guys technically have options. For most of you, I think getting a 3 over 3 would be helpful in doing a common denominator, just from creating that T-proof quiz that you guys will get back tomorrow in preparation for studying for your test. I think most of your brains think like this, which is okay. You can do the same thing down here. 3 plus red 3 over 3. 3 plus red 3 over 3. Some of you can see that we can just simplify these over 3s because they are in the same exact position on top and bottom. We could also multiply by the reciprocal. It's what you always do in dividing fractions. And then just a few of you realize, stink, the book is totally going to make me go further because there's a radical in the denominator. So I have to multiply by the conjugate. This might be helpful for some of you just in simplifying some of the problems in homework. If there's a radical down there, they're going to expect you to simplify, which involves FOILing. So close to being the same thing. we have 3 rad 3 minus 3 minus 9 plus 3 rad 3 all over 9 minus 3, which is 6 rad 3 minus 12 all over 6, which some of you realize there are 6 all over the place. Technically, the proper form of this would be negative 2 plus rad 3. Ugh, all of that was just getting it to be a nice simplified answer. So anyway, sorry. For those of you that did ask, you will come up against probably having to write it in a simplified fraction. So that's why I kept going. Sine and cosine won't be near as bad as far as plugging in because it's not a nasty fraction with a complex fraction with radicals, with needing to rationalize the denominator, with all that jazz. Shouldn't be as bad. But sorry, I realized we hadn't done a tangent one, and those are kind of nasty to simplify. That was number 14. Help. 27 was the next one, Nikki? Okay. Number 27, different section, different, whoops, directions. Oh, but so nice if you have the formulas in front of you, and if you remember, you can work forwards or backwards. Why am I saying or backwards? Is there a formula that has a sine of u cosine v minus cosine v sine u? Yes. But it's on the other side. The computer says no today. So I'm going to go backwards. Because, oops, this formula comes from a sine of, it's this side, of a sine of u, saying minus v. The cool thing is I can recognize it and be like, oh, hey, he came from sine of who? 3 minus who? 1.2. I'm down to sine of 1.8. And to be honest, they don't even make me keep going because I can't keep going, at least as far as doing that exactly. I don't know what 1.8 is as an angle. That's gross, but I can rewrite it as an expression of sine of an angle. I'm done. Nathan.
The last one, 14?
Yeah.
For tangent. You plug it in the calculator, just a negative 1.
Are you in gradient mode?
No.
Plugging in negative pi over 12 has to be gradient mode. Double check it. Because negative pi over 12 as a degree would be...
Still negative 1.
Oh, tangent. And you're making sure you're putting all that in parentheses? Any other gradient mode? Makes no sense because tangent is negative 1 at negative pi over 4, which is a very different answer. But let me go ahead and do it too. You're not doing second tan, right? Mm-hmm.
Like when you scroll up a little bit to S, you focus
Oh, you mean my final answer? Mine? Your questions? Nathan's saying that way earlier in the problem I could have just reduced everything to be a negative 1. So I'm just checking my work real fast. Oh, you forgot that in the tangent formula, there's a subtraction on top when there's an addition on bottom. You wrote a subtraction for both. So their signs are always opposite, so double check your formula. Yours is -1, but mine wasn't. Yeah. Oh, got that one. And then 36. 36 was a whole other section, right? And he's saying find the... What's gorgeous about it? It's just like the other one in that you can go backwards. So you have to look on the other side of the formula also. So you got used to, hopefully, Nikki, going forwards with cosine u plus v sine of u minus v to the longer form. We can go the other direction. Very similar, because you just have to figure out who's co-co, this guy. U and v. And then change, right? Yeah. So you're just going the other direction from what your brain is used to.
That's all I want.
Well, you have to keep going and then ask yourself. It's saying exact, so it's saying there must be a way. I mean, you could have done it one by... No, you can't. You can't do 16ths, right? But wait a minute. When I put them together, isn't that 4 pi over 16, which is the only way to do it exactly, geometrically, trigonometrically, is to say, oh, I got them. To go the other direction. Your face right now. Why didn't we do that for these guys with the over 12s? Like, why did we break it up and make it hard? Because it was impossible. This guy, it was actually impossible broken up. It was much more possible. Okay, section 5.5. I know. We're right here at the end. But actually, guys, the examples that we did today will be super helpful for section 5.5 examples tomorrow. Now listen. Section 5.5. I've already told you from that last page right before our review in our book, where all the formulas are listed from 5.1 all the way to 5.5, that you need to make a formula page and be memorizing all of them except for the last big box, right? What are we going to do tomorrow? 4 bonus. 4 bonus. 4 bonus. I want you guys to make a formula page of all the formulas you need to memorize. And to be honest, if I were you, no, I won't get bonus unless you do all the formulas, including the ones you don't have to memorize. And here's why. I don't want to spend the majority of time tomorrow with you guys writing down formulas that you should be studying already anyway. And let me show you what I mean. Here we go, in section 5. Formulas, example. Formulas, more examples. Formulas, more examples. Formulas, more examples. Formulas, more examples. There is no point to us writing down formulas tomorrow because you're already supposed to be studying and having a reference page for problems. We're only practicing 5.5 tomorrow because you guys are going to make a formula sheet tonight if you haven't yet already of all the formulas. And if you do it, I'll give you bonus. 5.4.